Some time ago, browsing a very old magazine, I found this observation test about the story of the ark. And the artist that drew this observation test did some errors, had some mistakes, are more or less 12 mistakes. Some of them are very easy. There is a funnel, an aerial part, a lamp, and clockwork key on the ark. Some of them are about the animals, the number. But there is a much more fundamental mistakes in the overall story of the arks that is not reported here. And this problem is, where are the plants? So now we have God that is going to submerge Earth permanently, or at least for a very long period, and no one is taking care of plants. Noah needs to take two of every kind of bird, of every kind of animal, of every kind of creature that moves, but no mention about plants. Why? In another part of the same story, all the living creatures are just the living creatures that came out from the ark. So birds, livestock, and wild animals. Plants are not living creatures. This is the point. It's a point that is not coming out from the Bible, but it's something that it's really accompanied the humanity. Let's have a look at this nice code that is coming from a Renaissance book. Here we have the description of the order of nature. It's a nice description because it's starting from left, you have the stones. Immediately after the stones, the plants that are just able to live. We have the animals that are able to live and to sense. And on the top of the pyramid, there is the man. It's not the common man. It's the homo studiosus, the studying man. This is quite comforting for people like me. I'm a professor. To be over there on the top of a creation, but it's something completely wrong. You know very well about professor, but it's also wrong about plants. Because plants are not just able to live, they are able to sense. They are much more sophisticated in sensing than animals. Just to give you an example, every single root apex is able to detect and to monitor concurrently and continuously at least 15 different chemical and physical parameters. And they are also able to show and to exhibit such a wonderful and complex behavior that can be described just with the term of intelligence. Well, but this is something, this underestimation of plants is something that is always with us. Let's have a look at this short movie now. We have David Attenborough. Now, David Attenborough is really a plant lover. He did some of the most beautiful movies about plant behavior. Now, when he speaks about plants, everything is correct. When he speaks about animals, tend to remove the fact that plants exist. The blue whale, the biggest creature that exists on the planet, that is wrong. Completely wrong. The blue whale, it's a dwarf. If compared with the real biggest creature that exists on the planet, that is this wonderful, magnificent Sequoiadendron giganteum. And this is a living organism that have a mass of at least 2,000 tons. Now, the story that plants are some low-level organisms has been formalized many times ago by Aristotle, that in the Anima, that it's a very influential book for the Western civilization, wrote that the plants are on the edge between living and non-living. They have just a kind of very low-level soul. It's called the vegetative soul, and because they lack movement, and so they don't need to sense. Let's see. This is, okay, some of the movement of the plants are very well known. This is a very fast movement. This is a Dionea, a Venus flytrap, hunting snails. Sorry for the snail. This has been something that has been refused for centuries. Despite the evidence, no one can say that the plants was able to eat animals, because it was against the order of nature. But plants are also able to show a lot of movements. Some of them are very well known, like the flowering. It's just a question to use some techniques like the time lapse. Some of them are much more sophisticated. Look at this young beings that it's moving to catch the light every time, and it's really so graceful. It's like a dancing angel. They are also able to play. They are really playing. These are young sunflowers. And what they are doing is they cannot be described with any other term than playing. They are training themselves like as many young animals do to the adult life, where they will be called to track the sun all the day. They are able to respond to gravity, of course, so the shoots are growing against the vector of gravity and the roots toward the vector of gravity. But they are also able to sleep. This is what Mimosa pudica. So during the night, they call the leaves and reduce the movements. And during the day, you have the opening of the leaves and much more movement. So this is interesting because the sleeping machinery, it's perfectly conserved. It's the same in plants, in insects, in the animals. And so if you need to study sleeping problem, it's much more easy to study on plants, for example, and that in animals, and it's much more easy even ethically. It's a kind of vegetarian experimentation. Plants are even able to communicate. They are extraordinary communicators. They communicate with other plants. They are able to distinguish kin and non-kin. They communicate with plants of other species. And they communicate with animals by producing chemical volatiles. For example, during the pollination. Now, the pollination is a very serious issue for plants because they need to move the pollen from one flower to the other, and they cannot move from one flower to the other, so they need a vector. And this vector is normally an animal. Many insects has been used by plants as vector for the transport of the pollination, but not just insects, even birds, reptiles, and mammals like bats and rats are normally used for the transportation of the pollen. This is a serious business. We have the plants that are giving to the animals a kind of sweet substance, very energizing, having in change this transportation of the pollen. But some plants are manipulating animals, like in the case of orchids that promise sex and nectar and give in change nothing for the transportation of the pollen. Now, there is a big problem behind all this behavior that we have seen. How is it possible to do this without a brain? We need to wait until 1880 when this big man, Charles Darwin, published a wonderful, astonishing book that it's a revolution. The title is The Power of Movement in Plants. No one was allowed to speak about movement in plants before Charles Darwin. In this book, assisted by his son Francis, that was the first professor of plant physiology in the world in Cambridge, they took in consideration every single movement for 500 pages. And in the last paragraph of the book, that it's a kind of stylistic mark, because normally Charles Darwin stored in the last paragraph of a book the most important message. He wrote that it's hardly an exaggeration to say that the tip of the radicle acts like the brain of one of the lower animals. This is not a metaphor. He wrote some very interesting letter to one of his friends that was J.D. Hooker, at that time president of the Royal Society, so the maximum scientific authority in Britain, speaking about the brain in the plants. Now, this is a root apex growing against the slope. So you can recognize this kind of movement. The same movement that worms, snake, and every animals that are moving on the ground without legs, it's able to display. And it's not an easy movement, because to have this kind of movement, you need to move different regions of the roots and to synchronize this different region without having a brain. So we studied the root apex, and we found that there is a specific region that is here depicted in blue that is called the transition zone. And this region, it's a very small region. It's less than 1 millimeters. And in this small region, you have the highest consumption of oxygen in the plants, and more important, you have this kind of signals here. The signals that you are seeing here are action potential, are the same signals that the neurons of my brain, of our brain, it's used to exchange information. Now, we know that a root apex have just a few hundred cells that show this kind of feature. But we know how big is the root apparatus of a small plant, like a plant of rye. We have almost 14 million of roots. We have almost 11.5 million of root apex, and a total length of 600 and more kilometers and a very high surface area. Now let's imagine that each single root apex is working in network with all the others. Here we have on the left internet, and on the right the root apparatus. They work in the same way. They are a network of small computing machine working in networks. And why they are so similar? Because they evolved for the same reason, to survive predation. It's the same, they work in the same way, so you can remove 90% of the root apparatus and the plants follow to work. You can remove 90% of the internet and it is following to work. So a suggestion for the people working with networks. Plants are able to give you good suggestion about to evolve networks. And another possibility is a technological possibility. Let's imagine that we can build robots, and robots that are inspired by plants. Until now, the man was inspired just by the man or by the animals in producing a robot. We have the animaloid, and the normal robots inspired by animals, insectoid, and so on. We have the androids that are inspired by the man. But why we have not any plantoid? Well, if you want to fly, it's good that you look at the bird to be inspired by bird. But if you want to explore soils, or if you want to colonize new territory, the best thing that you can do is to be inspired by plants that are master in doing this. We have another possibility. We are working in our lab, is to build hybrids. It's much more easy to build hybrids. Hybrids means something that is half living and half machine. It's much more easy to work with plants than with animals. They have computing power, they have electrical signals. The connection with the machine is much more easy, much more even ethically possible. And these are three possibilities that we are working on to build hybrids driven by algae or by the leaves, and at the end, by the most powerful part of the plants, by the roots. Well, thank you for your attention, and before finish, I would like to reassure that no snails were harmed in making this presentation. Thank you.